guys, one more here. Geometric sequences, kind of the flip side to the arithmetic sequences we were just talking about. Geometric sequence is a sequence that grows through multiplication. And just like before, when I say multiplication, division would be okay too, because that's really multiplying by a fraction. This time, because we're multiplying, we don't call it a common difference, we call it a common ratio. And so now we're going to use the letter R. So just as an example, because we haven't looked at one of these yet, a geometric sequence might look something like this. 2, 6, 18, 54. Oh, I'm stretching the limits of my mental math here. Let's see, 162, and so on. So what's really happening here is I'm multiplying by 3 every time. And that multiplying by 3 is what's called my R value. All right. And you'll notice these sequences grow much faster because these are actually exponential functions. So the recursive formula for these guys looks really similar. Okay. Recursive formula looks something like this. We would say term 1 equals whatever. Okay. And then we would say, to get to any other term, we take the previous term, except this time we're multiplying instead of adding. And then that thing that we're multiplying by is really our R value that we talked about a second ago. Okay, so this R value, that's the thing that we're multiplying by over and over again. The explicit formula, again, similar to what we talked about before, we would say we're always going to start at our first term, and then we're multiplying by R repeatedly. And if you think about multiplying repeatedly, that means we're going to be using an exponent up here, okay? And so let's again look at this specific example up here. That to get from here to here and here to here, I know I'm multiplying by 3. So if I wanted to get from term 1 to, let's say, term 8 again, I would multiply by 3 7 times, because to get from term 1 to term 8, that's going to take me 7 jumps. So to figure out my term 8 here, I would start with that first term of 2 and multiply by 3 from 1 to 8 would be 7 times. It would look something like that. Okay? And so in our formula, we're saying term 1 times our R value of 3. And then this, if I was looking for term 8, I would want to do a 7 here. So what I'm going to do is put an n minus 1 up here. Now, this n minus 1 is not the same as this n minus 1. This n minus 1 is talking about a previous term. This is talking about the number of jumps that you're taking. This n minus 1 is more similar to, let's see, I've got it back here, when we were doing the arithmetic sequence and we had an n minus 1 here. This is the same idea, okay, that you would want to multiply 1 fewer times than where you actually want to get to, because you're going from 1 to that position. Okay, so looking at example 5, is this geometric or arithmetic? And so really the question we're asking ourselves is, are we multiplying repeatedly or are we adding repeatedly? Well, I can see right away that we're not adding repeatedly, at least not with a constant number, because if I were adding, this is plus 2, this is plus 3, the next one would be 4.5, but as soon as I see that it's not adding by the same amount every time, I can rule out arithmetic. Okay, we're not adding a constant number here. So now I want to think about, am I multiplying by something? And to figure out that something, what I'm going to do is I'm going to take the second number and divide it by the first. 6 divided by 4 is 1.5. So that means that if I were to do 4 times 1.5, I would get to 6. And then I'm going to check it with the 9 and the 6 also. I'm going to go 9 divided by 6 is 1.5 also. So then 6 times 1.5 would take me to 9. Now, if I really wanted to be super thorough, I would go ahead and keep checking, right? I would make sure that that 1.5 holds true all the way down. So 9 times 1.5 is this. 13.5 times 1.5 is this. But because I only gave you 2 options here, this one must be geometric. Okay. By the way, neither works as well. You can have a function that, or a sequence that is not geometric or arithmetic. So I didn't give you that option here. But I just want you to be aware of that, just because it's not arithmetic doesn't always automatically mean it's geometric. Okay, so a recursive formula, we're pretty good at this by now. Term 1 is 4. Term n would come from taking the previous term and multiplying by 1.5 over and over again. For my explicit formula, I'm going to say term n equals, and I'm using this guy up here, okay? My term 1, which is 4, times 1.5, and then I'm always going to use an n minus 1 here. Anytime this is term 1, which it should be based on that formula, this is going to need to be an n minus 1. And we're going to talk a little more in detail about that with example 6, but I think I'm going to wait for example 6 until when I'm back on Monday. So I think this will be enough to get you through the homework assignment. Okay, I just got a low battery flash thing on my computer screen. You can probably see it. So that probably means it's time to wrap this up. But we're going to go ahead and wrap up section 8.1 here, and then we will go over whatever we need to when I'm back on Monday.